All right, here we go, people. Let's do this thing. All right, look. I want you guys to draw a box just like the carbon box on the periodic table. So, for example, I know you can find the little box here. There it is. On the periodic table, each element has a little box that it lives in. Inside that little box, you will see C. What does the C mean? Carbon. On top of that C, you will see a 6. On top of that C, you will see a 6. Below that C, you will see a 12.011.
Did you pick carbon for that reason?
See, maybe I did. All right, let me tell you what these numbers mean. So draw this, and we're going to label. You ready, Layla? The number 6 means the atomic number, and it is the number of protons. Okay, also called the atomic number. All right, let me tell you something about the atomic number. It never changes. It never changes. Okay? Never, ever changes. Never changes. Never changes. It doesn't change. For example, okay, you're a person. You're unique. Your DNA is unique. Can you gain weight?
Yeah.
Can you lose weight?
Yeah.
Can you lose a limb? Okay, if you lose a limb, is your baby born without a limb? No, why not? Because you still have your DNA, right? You never change that. Can you dye your hair? Can you cut your hair?
Yeah.
Do you change your DNA by doing those things? No. Elements never change their protons. The number 6 means carbon in the periodic table. That's what makes it carbon. Here's what you can change. This number down here. This number, if you notice, it's a decimal. And it is a decimal because it is the average atomic mass. It's an average atomic mass. And it is made of the number of protons plus the number of neutrons. Okay. An average atomic mass. For example, Devin Matthews walks around normally at 126 pounds. In November, he starts cutting weight to get down to 113 pounds. What is his average? Is his average 113? Is his average 126? It's in the middle. Okay? So this is an average of all the carbon atoms. Okay, so you need to know that. If you round this number, hold on, Votech, one more thing. If you round this number, what would it round to? 12. So when you round the number, that's called the mass number. Most often, you guys are going to use the mass number in your calculations. Okay? Most often. Okay, if you need to go. I'm going to put this on the YouTubes. All right, protons and neutrons. Protons and neutrons. Notice I have not said anything about electrons. No, it's not the same as a proton. Okay? Not the same. Here's the reason why I haven't said anything about electrons. Protons have a mass of 1. They weigh something. They also have a charge of a positive 1. Okay? A neutron also has a mass of 1, but it has a charge of what? 0. So if you're neutral on something, you don't have a position. Neutral neutrons, nothing. 0. Neutral neutrons. But an electron has a mass of approximately 0 and a charge of negative 1. The electron is so small, its mass doesn't count. So we just say 0. Now, obviously it has a mass, but it's like
10 to the negative 19th size. It's so small, it rounds to 0. For example, okay, Petey weighs 182 pounds. Okay, 82. And the building weighs 182,000 tons. What is the difference between Petey and the weight of the whole school building? Petey's weight is absolutely 0 compared to the weight of the school building. The weight of the school building weighs 182,000 tons. It won't matter if Petey's here or not. It's still going to be 182,000 tons. The size of an electron compared to the size of a proton and a neutron is so small, it doesn't matter. Doesn't matter. So an approximate mass is 0. Now, how are you going to count the number of electrons? Here's how you're going to count the number of electrons. You ready? All right. The number of electrons. Okay, if you want to find the number of electrons, and you take the protons, the number of protons, and you subtract the charge. And what a charge is on the atom is it will be a plus or it will be a minus sign. Okay? Right now, carbon doesn't have anything. It doesn't have a charge. It doesn't have a charge right now. So it would be just whatever the protons are minus 0. But if it has a charge, then you would subtract it from the number of protons to find the number of electrons. Okay? Now, let's review one more time before I close this out here. Savannah's 1 and 2. How can you tell the number of protons? What do you look at? Atomic number. Okay? Can you find the number of neutrons by looking at the mass number? Can you calculate the number of neutrons? Can you calculate the number of neutrons from the mass number? Yes, you can. You can calculate the number of neutrons from the mass number and the number of protons. The number of electrons is found by doing the number of protons minus the charge. Okay? All that information you're going to need to know.